Welcome to the lesson on Factor Theorem. At the end of this lesson, you will be able to state the Factor Theorem and apply it to factorize polynomials. A polynomial is an algebraic expression consisting of multiple terms of variables and constants. These terms are combined by using mathematical operators, addition, subtraction, and multiplication. The exponents of variables must be whole numbers. A term can be a variable, a constant, or a product of the two. A real number that precedes the variable is called the coefficient. The variable of this polynomial is x. Hence it can be represented as p of x, which is the general form of representing polynomials. In this polynomial, the highest degree of x is 2. Thus, this is a quadratic polynomial. Now, let's factorize this polynomial. Here, we will write the polynomial in the form of this algebraic identity. This method of factorization of a polynomial is also known as splitting the middle term. The factors of this polynomial are x minus 2 and x minus 3. Now, we'll substitute x equal to 2 in the polynomial. We get p of 2 equal to 0. Similarly, we'll substitute x equal to 3 in the polynomial. We get p of 3 equal to 0. Based on the above discussion, we can sum up that p of 2 is equal to 0 if and only if x minus 2 is a factor. Similarly, p of 3 is equal to 0 if and only if x minus 3 is a factor. Let's generalize this for any real value of x. Consider p of x is a polynomial and a is a real number. If p of a is equal to 0, then x minus a is a factor of the polynomial. This is known as the factor theorem. This theorem is an extension of the remainder theorem. If the remainder becomes 0, then you can say that x minus a is a factor of p of x. Conversely, if x minus a is a factor of p of x, then p of a is equal to 0. The factor theorem can be used to factorize a polynomial or verify that a linear polynomial is a factor of another polynomial. Let's factorize this quadratic polynomial using the factor theorem. We'll find the factors of the constant term minus 4. Next, we'll substitute the factors in the polynomial. Let's begin by substituting 1 in the polynomial. Here the polynomial becomes 0. Based on the factor theorem, we can say that x minus 1 is a factor of the polynomial. By performing the same for all factors, we get p of minus 4 is equal to 0. Therefore, x plus 4 is also a factor of p of x. This can also be obtained by dividing the polynomial by x minus 1. The obtained linear polynomials are the factors of the quadratic polynomial. Let's recap. The factor theorem states that p of x is a polynomial and a is a real number. If p of a equals 0, then x minus a is a factor of p of x. The converse is also true.